Hello. Hello. Hello.
Yes, sir.
Okay. My voice is clear?
Yes, sir. Yes.
Okay. Okay. Uh, Today we'll be having half an hour only, half an hour lecture. So we'll be having revision of last two lectures. And Ashish Zadav sir is going to conduct your lecture from 2:30 onwards. So we'll be having a little bit of quick revision of what we have done in last two lectures. As this unit is quite a big unit, it requires somewhat like 10 to 12 lectures. A revision is must because you'll not understand what is happening in the coming lectures. So the revision by far is most important thing in which we have to conduct. Even we finish this lecture, these units, after that we are going to carry over two revisions in half of sections so that we can get aware of all these things once again. This unit is quite a big unit and it requires a lot of study. It requires a lot of understanding. Otherwise, rest of the 5 units are very simple. They you can easily do it. So let us have a revision of 2.3.7 and 3.8. That is 7th and 8th lecture, and then we'll be having tomorrow. We'll be having the next uh, lecture revision. So first concept, vector table. So I have said that whenever the exception event takes place on the Cortex M3 and accepted by the processor core, the corresponding exception handler is executed. And in order to determine the starting address of this exception handler, a vector table mechanism is used. This vector table is nothing but the array of word data inside the system memory, and each representing the starting address of the exceptional type. The vector table is relocatable and can be relocation of the controller controlled by, and the relocation is controlled by the relocation register in NVIC, that is non-vectored interrupt controller. After reset, the vector table is relocated to the address which has been at the x 0 0 0th position after the reset. So these are the exception numbers. So right from 0 to 13, these are the different number of exceptions, and from 14 to 255, these are some of the things. Now in order to understand this exception through with the help of vector table, let us assume that number one exception number is 1. So that start value of the MSP and reset. So if we're going to take the reset value, 0 is the starting value of main stack pointer. So that is a different case. Reset, when you are having the exception number 1, that means you're having reset vector. And this reset vector is 1 times 4. That is, each word is 4 bytes, which will be equal to 000 into 4. If I'm going to take the second exception number, that is NMI, that is non-mask interruptible, at that time the location will be plus 4 added into that, so it will be 000008, and the address 000 is used to store the starting value of main stack pointer. So have you got this one, like 0 1 and 2? I have explained these things. 0 is the starting value of MSP, reset 1, so the address will be 00004, and second will be the second exception number will be the NMI, which will be plus 4 more added as 4, so it will be 00008. So in this way you can study the vector table. Now in order to understand the embedded programs for the cheap peripherals, we need to understand C and assembly language. So if you get the summary of that, C is a portable and easy to learn and very easy to handle the complex data. These are the advantages of C. Whereas the assembly advantages allow direct control to each instruction step and all the memory, whereas allow the direct access to the instruction that cannot be generated by C. Whereas the disadvantages of C is limited or no direct access to the core register and stack, and no direct control over instruction sequence generation. So assembly takes a little bit of longer time to learn and difficult to manage the data structures, and it is less portable. So the big difference is it's portable, it is less portable, it is easy to learn. This is difficult to learn little bit. It is easy handling of complex data, and here little bit difficult to manage the data structures. So normally system on chip programmer typically uses the mixing of C as well as assembly languages all together. Then this is the typical program generation flow. So you can see that the code, C code, compiler, then it is assembler code to convert it to machine language code. Then it is linked through the program image, that is executable file, and then it is downloaded through the program memory, where it is instruction is fetched by the processor, then it is decoded, executed, and then it is processed, so data in and data out. So this is a typical generation program flow. In this case, normally the generation of the program flow happens like compiling, assembly, then link, and then downloading it. And the generated executable file or the program image is actually stored in the program memory, that is normally on the chip flash memory, to be fetched by the processor. And we are going to see now the how program in high level language such as C are generated and then downloaded into the hardware in the next slide. So this is the program generation flow with ARM tool. So it can be done in two ways. One is that it is using C source code, and the other one is using the assembly source code. So the C source code is it is compiled through the compiler, and it is converted into the object files. Whereas through assembly source code, it is been using ASM, it is converted into the object files. Plus assembly, it is having the library files also. So both will be linked together with ARM link, and then the program image where executable file will be generated. Then it will be downloaded to program memory, which will be in the binary form. So you can see with this explanation also, like in first stage, the compilation happens where the program is translated from high level language to assembly level language of a specific processor. Then this assembly language cannot be understood by the processor, hence it is converted into the machine codes, and this can be done by the assembler. In the next stage, the object code file will be generated by the link together with the object code, and this is an executable file which is stored in the program image. Then the ARM tool based flow, however, supports both assembly and C language, whereas CC tool converts the C source code directly into the object code, and the assembler will be converting the assembly language into the object code. So both will be linked together with the help of ARP link. This is the program image, vector table, C library code, program code, startup routine, and code region. So program image, actually, we can understand the compilation of program from high level language to the binary file. We are going to examine the content of program image of the Cortex. It refers to piece of fully integrated code that is ready to execute. And in Cortex M3, the program image is stored in the code region of memory map. The program image includes number of things like vector table, C startup routine, program code, C library code, etc. The vector table contains the starting address. We know that starting address of the exception or vectors. It also contains the initial value of main stack pointer. This is stored in the first word of vector table, and it can be programmed in C or assembly. Then the program code includes the sequence of instruction which corresponds to the program being executed. In addition to the part of the program includes the type of information such as initial value, variable, constant value, peripheral addresses, character strings, lookup table, and graphic image data. So the thing is that the startup routine is a part of a program image. 0 is used to initialize the data memory variables with unlimited at load times. It also sets up the data memory such as global data variable. The startup routine is automatically added to the program image by the compiler or linker, and it is then labeled as main by the ARM compiler, but may have different label if used by the other compilers. So this is about the program image. Now we'll move on to the next slide. So this is the program image in global memory. So the code is mainly useful for program image, example on chip flash, whereas SRAM mainly used for data memory, example on chip RAM, SD RAM. then peripherals, external RAM, external devices, peripheral bus, and reserved. So normally in Cortex M3, the program image is stored in the code region, which is in the global memory of up to 512 MB, and the range of the address is from 000 to FFFF. It is usually implemented on non-volatile memory such as on-chip flash memory. It is normally separated from program data which is allocated to SRAM, that is region, and this type of program data which can be supported depends on the process architecture and compiler. It is having 4 data sizes are supported in ARM programming, that is byte 8-bit, half word 16-bit, word and double word 64-bit. So this is how the data type is there, which is supported by Cortex M3. There is character byte, short half word, then the long words, long double words, float word, double long double words, pointer word. So these are the things. Then data qualifiers in C language are of two types. One is constant and second one is volatile. Constant is written in the program where you cannot change the value once it is allotted, and it can be put into ROM in order to save the space of RAM. Whereas in volatile, actually it cannot be optimized, but it can be changed as per your requirement. The can be changed outside of normal program. Low ISR hardware register. Compiler must not optimize the access to volatile variables. Flags set by the interrupt routine should be marked as volatile, and memory map peripheral registers should be marked as volatile. These are the important things. As we know that it is having two qualifiers, constant and volatile. Constant means something that is not modifiable. So it can be declared, that means you cannot alter in execution of the program. Whereas in case of volatile qualifier, you can specify the data, you can change the volatile type of data qualifier at any time. Therefore it must be read from the memory each time it is accessed. So जब जब उसकी जरूरत पड़ेगी एक्सेस करने की, तब तक वो रीड होना चाहिए, क्योंकि वो मॉडिफाइबल है, वो मॉडिफाई हो सकता है. This qualifier is most often found in code that control hardware directly, such as embedded system and device drivers. Device drivers. So how the data is stored into RAM? It is stored in 3 different regions. One is your static data, stack, and then heap. Static data contains the global variables and static variables. Stack contains the temporary data from local variables, whereas heap contains the pieces of memory spaces that are dynamically reserved for allocation and memory allocation. The RAM in microcontroller is used in different way. So these are the data actually stored in volatile memory, with example of static RAM, and the another example is usually stored in non-volatile memory. That is example is flash on chip. Then by far we know that the program image is stored in the code region in the global memory, which is having a size of up to 512 MB, which is a non-volatile memory, that is flash chip memory on chip. Then we also know that the program data is normally separated from program image and allocated in SRAM. Then example of global variable D equal to 31, which is stored in the static data, because the global variable is stored in the static data region. Constant C is actually stored in the startup routine of the program image in order to save the space of SRAM. And the addition, that is A equal to D plus 7, will be stored in program code region in flash memory. This is the serial communication. As we know that there are two types of serial communications. One is there are two types of communication. One is a serial and the other one is parallel communication. Serial communication, as it depends, in serial communication there is no costing of wires, and as the 1 by 1 bit sequence is generated, so it is useful for long haul communication and the communication between modem and non-network communication. It is having limitation that the speed is little bit of less as compared to serial communication. At parallel, you do have speed good enough. So if, as far as serial mode transmission is concerned, it can connect like computer and modem together with RS-232 protocol. Then analog interfacing data acquisition, we know that the embedded systems often need to measure the physical parameters which are continuous in nature, like temperature, light, pressure, acceleration, and others. So we can give it to the comparator so that that one will be v input that you receive from the different sensors, and the other one is v reference, which is already stored there. So the comparison will be done, and if the comparison is okay, the one bit will be send off. In this way you can have the analog interfacing. You can calculate the value of depth, pressure, etc. Then this is for the example of analog and digital values. So sensor detects pressure and generate a proportional output voltage, that is V sensor, which is analog in nature. It is given to analog to digital converter. Then it will be compared with the V reference and V sensor, and accordingly the digital code will be generated. Now this digital code will be very much useful in order to help in which will be helpful to get something more useful. So this is how you can also get an example of analog and digital values. This is once you've done analog to digital conversion, then digital to analog conversion is also possible. You can see with this example that how it could be done. So we can get an output voltage as v reference into n by 2n, or v out equal to v reference into n plus 1 by 2n, where the offset plus 1 term depends on internal configuration of DAC, and we can check the data sheet for the same. So I do feel so this is the revision of lecture number 7 and lecture number 8. Yes, have you got some questions regarding this? Hello. 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 Hello.